Thank you, Marcia. And just a comment on the format. What we're going to do is provide each of the panelists an opportunity to provide some introductory remarks. Then I've got a couple questions we'll start off with, and then it's such a small group. I'm just going to turn it over to the audience, and we'll conclude the program with Q&A with the audience. I'm going to turn to David Cohen now, who is the co-founder and CEO of Infotility. And David has over 20 years of experience working with energy and software industry, specializing in renewable energy, energy intelligence, internet-based software, and distributed energy. He's developed numerous commercially available software platforms and is nationally known for his pioneering work in distributed energy research and development. Infotility is currently leading the development of next-generation intelligent agent-based software infrastructure. On one of our calls, David spoke quite a bit about microgrids, and I'm sure he'll talk about that today. David serves on the board of Gridwise Architecture Council and is a member of Gridwise Alliance, Modern Grid Initiative, Galvin Initiative Microgrid Working Group, and is co-chair of ACORE, which is the American Council on Renewable Energy's CEO Council. So why don't you come up here while I get your presentation on the screen here.
I'm going to probably go through my slides pretty quickly since we do have a Q&A session, and I want to talk about the perspective of distributed intelligence and how that applies to the fact that there's lots of things that are going on in the network that weren't there before, and looking at more from a software architecture and also talking about what we're doing in the space related to distributed intelligence. Specifically, we've been developing an agent-based platform. We deployed it in Australia. In Con Edison, they have a system called 3G System of the Future, and it's a next-generation network design. We're looking at compact networks that are sort of microgrids, where you have a couple of buildings on a feeder that are sort of separated from the rest of the network, and you look at how to resolve issues locally. We're also doing some large-scale integration of renewables in Marin County, and I'm going to talk about that. What is an agent? It's really a software program, computer system that's capable of, in terms of the way we look at it, it's capable of a flexible, I would say semi-autonomous action in dynamic, unpredictable environments, which is what the grid is. It's a little bit different than the traditional centralized control, and there's lots of agreement from most of the major initiatives about the fact that agents are a necessary part of the smart grid problem. They don't solve the problem, but they certainly are going to be needed to coordinate with the centralized systems. And we like to think of them as being adaptive to changing conditions, which gives a lot of the benefit of an agent-based platform. Is essentially there's all this stuff going on at the edge of the network, and you don't always have time. In the case of what Marcia was talking about, you don't always have time to get all the data back in real time. Some of these transactions are very, very fast. And in the case of relays, the milliseconds. So you need to have coordination behavior. And another thing we think about is how they can really kind of coordinate with each other, kind of like a baseball team doing a play, where you have all this stuff going on and the play gets done, and that's a way to solve problems. So we think of agents as being able to model things that are on the grid. So things like fuel cells and photovoltaic panels and demand response services, things like that can have models that we can understand the behavior. So an agent can represent different things on the grid. It can represent thermostats and relays and different types of aspects of things that are part of the electrical distribution system. And when you put them all together, you can have these communities of smart managed device networks, as Marcia was talking about. You have systems that you can manage the software, but when you think about it from a localized perspective, if you're going to manage this building, you could have agents managing all the dimmable ballasts in this building, coordinating with something at the building level, coordinating with something back at the utility. And what you need is different levels of hierarchical control. So agents represent a great way to do control where you're talking about distributed at the edge, where they're managing a community of things on the network. Similar to what's currently going on with control in utilities, but again, we're now pushing a lot of this stuff out much farther than traditional SCADA systems have been able to manage. So going back on Dave's comments, Modern Grid Initiative, GridWise, have come up with these smart grid characteristics as well as EPRI. I'm going to focus on the distributed participation and control aspect today, as well as some of the self-healing aspects when we get into microgrids. So some of the forces that have been really happening that are corollary to some of the other industries are the idea of going from centralized systems to distributed to then network, which means you have distributed and centralized mixed together and everything's connected, and that's really what is happening with the smart grid. The other aspect of what's happening in the smart grid that happened in other industries is this idea of passive to transactive. So in the end, when you have starting up with a one-way power flow, power going from a nuclear power plant down to the end and using power, we're now talking about where buildings and homes and microgrids are now pushing power back, which is completely different. It's a transactive network. You can even have a transactive room here where these lights start dimming according to the circumstances around them. We were working on a project back in 1990 actually with one of the Robert Dodier, who works for us on a smart home where it was adaptive to the actual characteristics of what was going on. So if people came into the kitchen, the lighting would actually change around them according to how many people, the voice levels and things like that. So there's all kinds of, you can go very deep into that whole aspect of the thing. The other part is central to distributed. This is just a diagram. I don't know if you can see it in detail, but it's Denmark. I think other people have seen this diagram.